All right, class, in this second video regarding systems of equations, a graphing method, we're going to look at examples that have no solution. Now, if you remember from the first video, I didn't really mention it, but all of the examples that were worked had exactly one solution, meaning that there was one point on the XY graph where those two lines crossed, and we said that was the solution. So most of the problems we will work will have a specific solution. But occasionally, we will come across some that have what we call no solution. And what that means is the two given lines, they're not actually a system. They don't actually cross. Now, what I hope you see in these first two examples, this one and this one, is that the second one needs to be written in the form of y equals mx plus b. And so to do that, you see the negative here. That means I'm going to have to add 2/3 x to both sides. And that gives me y is equal to 2/3 x minus 3. So now I'm dealing with this equation and this equation. So when we deal with the graphing, they both have to be written in the form of y equals mx plus b. So again, all the stuff that we've been working on for the last few months in multiple modules, it's leading us up to this point to be able to recognize this and take these initial steps before we can solve. Now, what I hope you see here is that they have the exact same slope. And there's the issue. That's why we're going to get no, well, that's part of the reason we're going to get no solution. They're parallel, but then also notice this. They're parallel lines, but this first one has a y-intercept of +1. This second one, -3. So the same slope, they're parallel. The other component, the y-intercepts are different. Let's graph them so you can see what I'm talking about. +1, and our slope is 2/3. So we're going to go up 2 and then over 3. And so there is our line. The second one, it starts at -3 here and goes up 2 over 3. 2 over 3. Now my lines are certainly not perfect, but they're pretty close. You can see that those two lines are parallel, and they're always going to remain parallel. They're never, ever, ever going to cross. And that means our answer is not, oh man, I did something wrong. I checked my math. I look for those components, same slope, meaning they're parallel, different y-intercept. That is a no solution. I want you to pause the video, try this practice problem, and then resume when you're done. All right, hopefully you did what I asked you to do. And so our first step is going to be to rewrite this top equation in the form of y equals mx plus b. So I'm going to add 2x to both sides. So now I'm dealing with y equals 2x plus 4 and y equals 2x. Now y equals 2x is direct variation. That's y-intercept is at 0, and then I'm going to go up 2 over 1, up 2 over 1. I could also go down 2 and to the left 1. Okay, and so that line is going to come right through there. But look at this. They have the same slope, don't they? But this one, the second one, starts at 4. 1, 2, 3, 4. It starts right there. Okay, and so it's going to graph like that. And they are parallel lines with different y-intercepts. That is an example of no solution. All right, let's look at another scenario. Again, now we've got one solution system of equations. They cross at one particular point. We have examples of no solution where the slope is the same for each equation and the y-intercept is different, so they're never going to cross. But what happens in a scenario like this, where we have infinite many solutions, meaning that I can plug any values I want in for x and y and it's going to work? Let me show you what I mean. So we need to take this bottom equation because it's not written in the correct form. I'm going to add 3 to both sides, plus 3, so that's going to give me a +1. So now I'm dealing with y equals 2x plus 1 and y equals 2x plus 1. It's the exact same equation. So I start at 1 and I go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. That's my slope. I draw the line through the dots, and that was this one. But wait, I'm going to have to do the second one. It's the exact same thing. So any point that I put on the line, why don't we just check this one? That's going to be -2 in the x, and 1, 2, 3, -3. So let's check point -2 and -3. So let's take our equation, plug in -3 for y. There's my slope times my x, -2 plus 1. So that's -3 equals -4 plus 1. Yep, it works. And that's -3 equals -3. I could plug in this point, which is 1 and 3. And it's going to work. It's going to give me a correct solution, meaning, like in this case, -3 on the left and -3 on the right. There are infinite many solutions. I can put anything I want in there as long as it's a point on this line. This one would work. That's going to be 2 in the x and 1, 2, 3, 4, 5 in the y. I could plug in 2 and 5, and that's going to work. The only condition is it has to be a point on the line. If I come out here and say 1, 2, 3, 4, 5, that's going to be 5 in the x and -2. No, that one won't work. It's not a point on the line. That's not going to work. If it's a point on the line, it works. All right, so pause the video and try this practice problem. All right, so here we recognize that we have one of our equations. That's correct. That's written in the form of y equals mx plus b. This top one is not. So it's a positive 1/3 x, so I'm going to have to subtract 1/3 x from both sides. And there we go. We can see that they are the same. So I go to 1, that's my y-intercept, and my slope is a -1/3. So I'm going to go down 1 and to the right 3, or I can go up 1 and to the left 3. Either way gives me a negative slope. And they both plot the same. That is infinite many solutions. Again, I can try any point on the line, and it's going to work. Why don't we try -3 and 2? So for our check problem, we're going to try the point -3 in the x and 2 in the y. And so let's plug in 2 for our y. -1/3 times -3 plus 1. That's going to go -1/3 of a -3 is a 1 plus 1. Yep, 1 plus 1 equals 2, doesn't it? It works. Again, you could try this one or this one. Any point on the line, plug it in. It's going to work. There are infinite many solutions because they have the same slope and the same y-intercept. They're always going to be on top of one another.